Hi Roberto, hi Yvonne.
Hi, hi.
How are you?
Great. I'm walking to the Institute of Mathematics.
Sorry,
Great. I am walking to the Institute of Mathematics.
you are?
Walking to
My
the Institute.
I
Yeah.
got it, I got it. Sorry.
Oh, no problem.
Your voice is very loud, so that's why your words were resembling to each other.
Yeah, like it's like saturation, right?
Yeah, so walking was coming out of the door, like walking was going out of the domain. Well, I could say that the last exam was good for all of you. You guys have performed well, so now I am little bit happy with that. So yeah, and I also can say that it was a really very easy exam, isn't it?
Yeah.
Because the first exam,
Yes.
all of you I think were scared. So I wanted to make this paper really easy, and the final exam will be like a more in more specific way. I would like to say that Yvonne and Camilo are aware of the exam label and all. So the exam was more difficult for Roberto and Rebecca and one Ricardo, but not this exam. All of them really performed well. So
We should be very happy for that.
sorry, you should be.
We should be very happy for that.
Ah, yeah, yeah. It is a moment to enjoy. So in the last classes, we were talking about the solution of the heat equation, and we also derived the function. I'm not gonna revise. I will just say a few words. So ut is equals to Laplacian of u. This was the heat equation, and using the method of separation of variable, we find out the solution of this heat equation. And later on, we derive that a function phi x comma t is equals to 1 over 4 pi t to the power n by 2 e to the power minus modulus of x square over 4t. X belongs to Rn, t is greater than 0 and 0, then x belongs to Rn and t is less than 0. So this function is the fundamental solution of the heat equation, and if you solve the one-dimensional heat equation, if you solve the one-dimensional heat equation, in one dimension the Laplacian of u will be uxx, and in that case this function reduced to 1 over 4 pi t square root 14, and also this modulus will be simply x square. And we proved that in the case of the one dimensional, the integration from 0 to uh, integration of r phi xt dx was one dimension. Even in the n dimensional, the integration over Rn phi xt dx is equals to 1. So in that case, in the case of n dimensional, we use the summation in the distributional sense. Summation in distributional sense. So at this moment we have this much idea. So if you guys have any doubt from things, then please ask to me. Is it clear how we did, and did you guys get a chance to revise all those things? I am assuming
I,
that.
I, um, I, I didn't revise them, but I remember them.
Okay, then fine. Because when we are proceeding now, I am going to prove some theorem. So the main idea. was to derive the fundamental solution of the heat equation, and at each step, and we have also defined this kind of thing that it is 0 when t is less than 0 and it is this when t is greater than 0. So it might also be valid because at t equals to 0 we will be having the initial condition, and when the heat equation we are writing in the sense of time, the evolution over time, evolution over time. So you guys can say that since the time is not going to be negative, so because of that it is coming to be 0 because we are not proceeding in the reverse, we are proceeding in the forward direction. So t is always greater than 0, so that's why this is a fundamental solution of the heat equation. So that is also a reasonable statement to say, and yeah. Next, I would like to write some definition. So we call the function k x comma y comma t is equals to phi x minus y comma t. I have just replaced this argument to x minus y. Just this argument to x minus y. Where x comma y is belonging to Rn and t is greater than 0. We call the function the heat kernel in Rn. So this heat kernel, it is going to play a very important role because what do you know about this heat kernel? What you can say formally about the heat kernel by seeing all the definition?
That the convergence of the solution.
No. What was this was the fundamental solution of the given heat equation, is not it? So when we are calling it a fundamental solution of the heat equation, so this property automatically comes, isn't it?
Oh yeah,
And
yeah.
when you change the argument to x minus y, is it not going to make any difference? So you can say that k
It's
x.
still normalized.
Yeah. So this is going to be 1, isn't it? It means the integration of the heat kernel over Rn is 1. So this is the most important property which we are going to use throughout our discussion. So this is the most important things to keep in your mind. Like these are very small things, and I want that when I am asking, you should answer me because I already know when you will strike over those things and you will try to catch those things. So proceeding with the theorem will be very easy for you. Like you are gonna understand each and every steps very clear. Now consider the initial value problem. or Cauchy problem of the heat equation ut is equals to Laplacian of u x comma 0 is equals to g of x in Rn comma 0 comma infinity, and in this is the boundary condition, or you can say the initial condition. So here, since this is the heat equation, the variable is evolving over the time as well as the space variable. So we are going to say that it is a initial value problem. It means the time t equals to 0. This is defined. So on Rn cross t equals to 0. So this is an initial value problem. So let us note that the function now define u x comma t is equals to Rn phi of x minus y comma t zy dy is equals to, now you guys already know that this is nothing but the heat kernel, so we can write the solution. So this will be the solution of the given initial value problem, in which the initial data is a general function of x. It is not a constant, because as soon as you will be taking it as a constant function like c, so this integration gy will be outside, and the integration, this integration will reduce to something e to the power minus mod of g square over 40, and then you can take, and that is going to be 1. That is going to be 1 with this value. Okay. So here, when the initial data is a general function of x at t equals to 0, in that case, this is the solution of the initial value problem. Now, there is one more thing I would like to recall from the previous classes. I think you guys remember u x plus u y equals to 0. Then we calculated the solution of this u x comma y is equals to integration r p x comma y, and the value at x comma 0 was defined as something phi, so phi d of x. Do you remember where p was the Poisson kernel?
Yeah.
So this is, in this case, this was the Poisson kernel, and phi was the value of the function at the boundary of the domain. Boundary of the domain. Now you can also relate to here. Here we saw, and here we also solving in the same way. So the solution of the initial value problem can be written in the terms of the heat kernel. Can be written in the terms of the heat kernel. Why we are calling it a heat kernel? Because it is function of x and y, and simultaneously it is also a function of t. So that's why it is heat kernel. And then we are writing it in the term of the value defined at the initial stage. In the terms of the value initial stage. So you can say that the value at the initial stage t equals to 0 is supported by the heat kernel kxy t. The value at the initial stage is supported by the heat kernel. Initial stage value is g of x. Is it clear? So this should also be a solution
Yes.
to the initial value problem of heat equation. You need to mention the initial value problem because in the wave equation we are also going to get the initial value problem, and in the heat equation we are also going to get the initial value problem. In both the cases, the variable the variable u, that is known as density variable, evolves over the time. So that's why we call it a initial value problem, because we will be given the value of this density function at time t equals to 0 in the heat equation as well as in the wave equation. However, in the Laplacian equation, it does not evolve over time, it only evolve over the spatial variable, it only evolve over the spatial variable. So that's why we call it a boundary value problem, because in that case we will be given some some definite boundary, whether it is interior boundary or it is exterior boundary. Now we are going to proceed to prove some theorem.
I have a question.
Sure, ask.
Why well, this is the way I see it. This is the way I see it. If the solution of the Laplace equation is the Poisson kernel, and the Poisson kernel is an integral form of a solution, why is it called Poisson kernel?
It was just a way to write it, and the more precisely I would like to recall.
But the name kernel reminds me to the kernel of a linear transformation.
Yeah, somehow related.
So I don't get like why a solution should be the zero solution or related to the zero of, oh yeah, it's the Poisson kernel for Poisson's equation equals to 0, right?
Yeah, and one more
Okay.
I would like to. That's why I was just coming to the point you are telling me. Yeah, so you are right. And what do you mean? What do you understand by the name kernel in the integral equation?
And from linear algebra, I just know that it's the set of all.
No, don't relate it to the linear algebra. Try to relate it to the integral equation. You already know the answer.
That if you applied something to that, it's equal to 0.
No. So, do you remember? Have you heard about the name colonel in an army?
No.
So, if you know about the army of a country, so there are colonels. So, the main role of colonel is to organize the organize the army and how they are going to proceed on the boundary, like how will they work on the boundary of that country. So colonel plays a very important role in the army. In the same way, colonel plays a very important role in the solution of a partial differential equation. If your kernel is changed, your solution is going to change. So that's why we call it kernel, because all the solution of the differential equation depend on that function kxy or kxyt in the heat equation. So that's why it's named as kernel. Now we call it Poisson kernel because at the source from 0, Laplacian of u equals 0, that is a Poisson equation in the term when f is equals to 0. Its solution is like Rn and then p xy and the value at the boundary and d of x. It is written like the boundary condition. The boundary is supported by this function. So that's why it is Poisson kernel. And also when f is not equals to 0, in that case we write this solution in the term of the Green's kernel because there we use some property like we multiply some support function and then we transform the integral on that support function and then we write it and then we use the property of the Green's formula and then we write it Green's kernel. In the same way when we come to the heat equation, in that case the initial solution, the initial condition is supported by this function, is supported by this function. So that's why first we put it heat and kernel because it plays a very important role in the solution of that heat equation. If this kernel is becoming very complicated, the solution is going to be very complicated. So that's why it is named kernel. Now if you want to ask some question, then you can ask.
Now every time I see every time uh, that I see like a question, I would think about like an army or something.
That's what that is what the way to explain it. Like I don't know what you call kernel in Mexico, but if you are talking about the army in another country, like I am from India, so I'm talking about India, even from the English-speaking country. So the main battalion, battalion in the army. So the person who handle all the battalion is the colonel. So according to the decision of the colonel, the battalion is going to change its position and the battalion is going to perform on the boundary. So the battalion, I like all the activities of the battalion depends on the decision of the colonel, how he direct them. So in the same way, like this is my definition, it is not
¿Puedo hacer
written
una
in
pregunta
India.
rápida? ¿Te gusta el café? Sí, me encanta, aunque ya no lo tomo. Es que a veces me hace así.
So that's why we call it
¿Qué más
colonel.
extrañas de tomar?
What do you call the person who
Café de casa. Lo mejor del café.
who direct
Please remember this channel.
group
Coronel.
coronel? Yeah, so in
Coronel. No, but that's different. That's what I'm asking. It's kernel, the kernel of a transformation, like not the coronel. Coronel is like it's it's a position in the army. The colonel has like all of these badges in his teacher and has like a lot of uh, of awards like in an army, you know, like the colonel. He's a person, but I didn't know that there was another concept in the military that was kernel, not coronel, kernel, and the kernel
in English you call
was
it
like a. I'm very confused.
in English we call it colonel, not coronel. We call it colonel. So if you will talk about the army of the Netherlands, are you going to talk about the army of the England?
But Colonel in the poison, yeah, that's yeah.
We call them colonel. Like who handle that battalion of the army. Like it is this was the way I remember what is the importance of kernel in the in an integral equation and also in the solution of a heat equation or Laplace equation. So it change all the solution, like all the solution nature depends on the kernel. What will be the nature of that kernel? Because the initial data is fixed, the boundary data is fixed. So only.
But coronel, the same word and the same spelling actually. It's colonel. In English, it's colonel without the R. It's colonel. That's the military rank. Like he's like a senior military officer rank. But kernel.
Mhm.
Kernel
Coronel.
is like
Respect to theta, we're gonna spin around.
Kernel.
It's gonna be from 0 to.
Kernel.
a group of people that just do like the intel
Or here we can differentiate pretty easily, right?
of some type of battalion, right?
No, the colonel is a military rank and it comes on the second rank, I think. So there is one superpower and he had some like a different kind of colonel. So that part of this country is handled by the colonel first. This part is handled by the colonel second. So there is a superpower like suppose prime minister.
So now that
Not prime minister for sure, but
again negative. Well, sorry.
like how I can say,
0 to 0.
I need to check the army rank even I don't remember. So there is a superpower of all the army and then they have divided colonels for each part of the country. So one colonel handles all the battalion of one group, the another colonel handle all the. It might have a different meanings, but it was just a way to explain it. Like you can relate it to the real problem, real life condition. So it was just a way to relate it.
Which is e to the 0, which is just 1. In other words, we just end up with.
Now I will have a master's in military ranks.
Oh no, even I don't. I am very curious to read a lot. I am very curious to know everything like geography, history, and these kind of things. I don't know for sure. I'm not perfect, but I know.
I knew, yeah, that's interesting. I knew that like the number, like the basic unit of like a military organization, like one person, like a one soldier, then like a binary system of persons. I didn't remember the word. That's why I'm. And then it escalates like to the army. That's very like interesting.
Yeah, like when we talk about the army, like who works on the land, and there is colonel and the army who works in the water. So there is another term. I remember the term because one of my family member is in that one. So it's for that in the water army. So
The
there
navy.
is Navy, yeah, but there is also a super person who's I don't remember this time because it is in my mind, but I just unable to recall. So it might be possible that in my family I have some army person, so I know. So let's see belongs to C.
So no one messes with you.
Sorry,
So no one messes with you.
no one messes.
With you.
Like I did not get the concept.
Yeah. So no one will mess with you if you have like somebody like in the military. Then you can scare them with
No,
that.
no, like if you don't.
I'm joking. I'm joking, bro. Just
I am also,
just
I am not getting offended, but I was just telling you the fact. When you belong to the army family, then you need to follow some particular rule and all. Because the army family is going to be very strict. But I am not. Like my
yeah.
relatives are in army, mine is not. So let G belongs to the continuous function over Rn intersection all the functions which are bounded over the infinity norm in the Rn and u be defined as and u is defined as the same. Let me um, what is the L infinity norm?
It's the essential supreme of the functions of the integral of the functions.
Would you please repeat integral supremum of the what you are saying?
Is the supremum
Of the integral or I if I remember
no.
the supremum, isn't it? It is only supremum of the functions.
Yeah,
Anyone else?
yeah,
Sorry?
the supremum of the function. Yeah, I think.
Yeah, so it is only supremum. When we talk about the L1 norm, then it is the modulus value of the integral, isn't it?
Yeah.
Yes.
Yeah, and when you will apply, like suppose we have the solution in this form, uxt is equals to integration of Rn, then you will apply, so you are just relating it with that since it, the
Or
solution
you
is,
can take the limit of the LP norm, and it also converges.
how it is related, would you please repeat what you are saying?
You can also take the limit when n tends to infinity of Ln norm. It
Yeah.
converges.
Yeah. So here our solution is already in the integration form. So that's why in your notes it is written in the integral form. In other, it is only the supremum of that function. Just so it is revising your functional analysis as well. You will defined as in the given initial value problem. Then this is the given initial value problem. Then the first condition u, if your z is belonging to C Rn intersection L infinity Rn. So G is continuous over Rn and also its supremum is finite. We are not talking about the differentiability of C. We are just talking about the continuity of the initial function G. Then U belongs to C. If it is so, in that case, U will be belonging to C infinity Rn cross 0 comma infinity, because this function z was defined at t equals to 0. T equals to 0, so it is free from t. If g belongs to the set of continuous function over Rn intersection L infinity function over Rn, then the solution is going to be infinitely continuous. Like it's infinite time you can derive it. Intersection L infinity Rn cross 0 comma infinity. The second ut is equals to Laplacian of u Rn cross 0 comma infinity. The third, the proof is super easy. For each x naught is belonging to Rn, limit. Today we are going to see this, and we are also going to see the Duhamel's principle. Like we will prove that if you are given a non-homogeneous heat equation with a homogeneous boundary condition, then that can be converted to the homogeneous heat equation with the non-homogeneous boundary condition. So we are going to see the proof. Now we have two information. The value of k or this function, can it be negative? Can anyone tell me? You guys already know.
No, it's positive.
It's positive and it is normalized over the Rn. So we have two information about kxyt, or you can say phi xyt. What is the date today? It's 30th October.
Yeah.
So we have two information. Clearly, the heat kernel kxyt is greater than 0 and it is normalized over Rn, that is kxy t dy is equals to 1 for all x belongs to Rn and t is greater than 0. Hence, modulus value of u x comma t. Just let me copy one thing, because you already know this solution, so I am copying it and will paste it there. This will be less than or equals to, we can take this modulus with L infinity norm on this, so the maximum value of this z of L infinity norm and the modulus over Rn kxy. We are just using some property of the function analysis, and that are very simple. I am assuming that you guys already know. And since this value is equals to 1, so this is equals to norm of z L infinity. Now, since this z is belonging to L infinity Rn and c of Rn, so in the view of that, we can say that the modulus value of this is going to be less than or equals to a finite value. You can write x belongs to Rn and t is greater than 0. So from here you can say u is belonging to L infinity Rn cross 0 comma infinity. Now the next statement, to u belongs to c infinity. I am going to write this statement. Furthermore, since k, x, y, t and along all derivatives are uniformly bounded on Rn cross. For the time derivative like k, x, y, t, so x, y belonging to Rn, and for time derivative we are choosing that t is greater than 0, so that's why we are choosing some delta. So for sure it is going to be greater than 0 because delta is some small positive constant. So uniformly bounded on Rn cross. We have the property of this kxyt because kxyt is coming in the form of exponential. So kxyt is coming in the form of exponential. So from here we can say that kxyt and its all derivative are uniformly bounded on this. Its all derivative are uniformly bounded on this. So we see that u will also belongs to c infinity Rn cross 0 comma infinity. Since its all derivative are uniformly bounded and its all derivative exist, so in that sense we can say that all the derivative of u also exists. That is, its derivative exists infinite time, it is bounded, so u will belongs to c infinity Rn cross 0. So u belongs to this one from this inequality, and with the property of kxyt, u belongs to this one. So it is belonging to the two sets, so it is also going to belongs to the intersection of those two sets. Furthermore, second, just let's come to the second one. Now we have to prove the second one. Now u t x comma t minus Laplacian of u x comma t. So it can be written as, for this one, integration over Rn so this is the definition. So when you will take the time derivative of this function ut x comma t, we will use the fundamental theorem of calculus. We will use the fundamental theorem of calculus. So the time derivative of this function, since this is independent of time, it is independent of time. So in that case, the derivative will only operate on phi t and g will remain as it is. Next, when we will apply the Laplacian of u, when we will apply the Laplacian of u, so it will be like integration over r Laplacian of phi z dy plus the upper limit is going to be 0, the derivative of the, and the derivative of the lower limit is going to be 0. And since this we are taking the Laplacian with respect to x only, and this variable y is treated as a constant when we are taking the Laplacian with respect to x. So this z will come out of this. So in that case, it can be written as phi of t minus Laplacian of x phi of f, because here it was only function of x, so we are taking the Laplacian with respect to x only, and this is function of x minus y comma t z of y dy. Now you guys already know that phi is fundamental solution of heat equation. So what does it imply? Can anyone respond me?
The first term in integral is 0, I think.
Yeah, so phi is fundamental solution of the heat equation ut is equals to Laplacian of u. So phi t is equals to Laplacian of phi is going to satisfy, because this is the fundamental solution. And what does it gives? Isn't it? So
Yeah.
this is 0. It means ut is equals to Laplacian of u x comma t. On this second proof, next comes to the third one. I told you now that this proof is very easy, but this proof will be useful in writing the solution using the Duhamel's principle. So that's why we are writing this theorem. Now fix x naught a fixed point from Rn and an epsilon greater than 0. Choose delta is greater than 0 such that modulus of zy minus gx naught is less than epsilon for all what does this called? In sentence, what you call it? I think Yvonne might be aware of this. This is real analysis. What?
This is this is just like the convergence of a
We call it uniform convergence, isn't it?
yeah, because it's for all the domain, right?
Yeah. So as soon as y is remains closer to x naught, zy always remains closer to cx naught. In the sense, when the difference of the two value y minus x naught is less than delta, in that case the function z approaches to gx naught or converges to gx naught in the uniform sense. So this is the definition of the uniform convergence. But we are not mentioning, we are just writing it because we are going to use it simply. Whose real analysis is good in this class? Like who can say that, oh, I know real analysis? Camilo?
Sorry, can you repeat the question, please?
Whose real analysis? Do you know a good real analysis?
No, I'm bad in that. in that topic.
Ricardo? Ricardo, how about your real analysis? Rebecca?
Normal, I suppose.
Do you know real analysis subject, good, like a good real analysis? Have you studied the course real analysis?
In bachelor.
Yeah, so it is good for you or not?
I think Rebecca is pretty good in real analysis.
Okay, she is good, it means.
Yeah, better than I am.
Ah, okay, so that's fine. And Roberto? Yeah, then, so I think because in most of this unit, we are going to use very simpler form of the real analysis, very basic. And that I don't want to mention because this is simply the definition of the uniform convergence. So in the same way, somewhere we are going to use the L infinity norm or basic of real analysis. Camilo, if you want to strengthen your real analysis, so you can follow some real analysis book like Bartley book or the book of real analysis. Um, I know only Bartley book, and yeah, I would also like to share you another book. I will send you an email. Yeah, that book is the calculus and mix of the real analysis and calculus, and I would strongly recommend you to go through that book.
Okay, thanks.
Yeah. Because the real analysis is the very base. Even I am not very good, but I know that much that I can survive. Then, if modulus of x minus x naught is less than delta by 2, we have modulus of u x t minus g x naught is equals to modulus of integration over Rn phi x minus y comma t g of y minus g of x naught dx. Just let me recall me. I am stuck at a point, I don't know where I am making the mistake. UXT is defined as, if anyone can suggest me, then please do. As this, and then minus g of x naught. How I am coming from this point to this point? Can anyone suggest me? I got it. Since this is a fixed value, isn't it? And this is a normalized kernel. This is a normalized kernel. So can we write it? The value of 1 is equals to. Can we write it?
Yes.
Yeah, I thought where I am, because I prepared this note last week and I just got stuck. Oops. Because each step should be clear to all of us. Because x naught is a fixed value, so gx naught is going to be a constant. Gx naught is going to be a constant. So whether you set it inside of the integral or you keep it outside of the integral, it is not going to make a major change. Yeah. So we are introducing this term because this phi is a heat kernel, so it is normalized, that is the integration of Rn phi is equals to 1. So we use this and then we pass this gx naught to inside of this integral. And then we can take phi x minus y comma t outside common, and this will be common, this will be g of y minus g of x naught dy. Now the next step will be, we will be adding g of x and subtracting g of x. So plus g of x minus g of x, and then we will break in two parts. The first part will be coming with yeah, that's fine. We will be adding this and subtracting this. Now we are going to talk about the, suppose this is the center x naught and this is the radius delta. So this represents a ball with center x naught and the radius delta. So we are going to write it like integration of b, no need to subtract or add, b x naught comma delta phi of x minus y comma t g of y minus g of x naught dy plus Rn. In the Rn, subtract this ball minus b of x naught comma delta. Now this x naught will be replaced with the general x. So phi x minus y comma t g of y minus g of x dy. Now I would like to ask a question. Can anyone tell me what is the motivation behind constructing this ball? Just have a look at this and tell me what is the motivation behind constructing this ball. And not equality, this will be less than alpha because we are writing this form inside of a ball and outside in the region outside of that ball. So can anyone tell me what is the motivation behind constructing this ball? Please tell me. Anyone please? Can we say that in this region for any y belonging to this ball?
To assure continuity or convergence or some sort of thing.
So yeah, that you are right. So basically in this ball, y is belonging to any value from this ball. So modulus of y minus center is not going to be less than radius. That is the equation of the circle. So inside the circle, this is going to satisfy. So we can use this property, isn't it?
Yeah.
Yeah. Every time if you are writing a statement, you are not getting them, please to ask to me because this is very crucial thing. I'm just writing in the flow. But if you will not working on that, then it might create a problem. So say this is I and say this is J. Now I is equals to integration of b x naught comma delta phi of x minus y comma t, the difference of gy minus gx naught dy. Here y is coming from this ball. So can we write, since in this ball y minus x naught is less than delta, so gy minus gx naught is going to be less than epsilon. So this value will automatically be less than epsilon. So this value will automatically be less than so I is going to be less than epsilon. Basically, we are going to show the convergence of this term. Sorry, basically we are going to show the convergence of this term, that is u will converge to g x naught in this case. So we have to prove that. And if the value of this integral over Rn is going to be 1. So isn't it the value of this, the normalized value over this, okay, let me write one more step. So we are going this integral over a small ball. So it will also be less than epsilon integral over Rn phi of x minus yt dy. And this is equals to 1. So I is less than epsilon. Do you guys have any doubt? Furthermore, if modulus of x minus x naught is less than delta by 2 and modulus of y minus x naught is greater than or equals to delta, then delta by 2, and that is less than or equals to x minus y plus half of y minus x naught. just using this property. Sorry, this property. Both are equivalent to say, or just pass this to this side. So modulus of y minus x naught minus half of modulus of y minus x naught is going to be less than or equals to modulus of y minus x. That is half this. Okay. Now we are coming to the j part. So we will pass this modulus value in two parts, and then we will use the L infinity norm. That modulus value is going to be less than or equals to L infinity norm. So it can be written as norm of C L infinity, and we are using 2 because norm zy minus zx L infinity is going to be less than or equals to norm of z by L infinity plus norm of gy L infinity. So to norm of g L infinity, the integration over Rn minus b x naught comma delta modulus value phi of x minus y comma t dy, and that can be written as what is the value of this function? The value of this function is this term, isn't it? The value of this function is this term. So simply if we use, this is a bounded function. This is a bounded function. So to norm of z L infinity, and when we use, so it is going to be 4 pi t to the power n by t. It will simply come outside of the integration, and integration over Rn minus b x naught comma delta phi of x minus y t dy e to the power minus mod of x minus y whole square over 4t dy. Since this term is a bounded quantity integrated, like a finite quantity integrated than 0, it is also a finite quantity. So assume that this x loop t 4 pi to norm of gl infinity over 4 pi is going to be some fixed quantity. So say it is c. Where c is equals to 2 norm of z L infinity 4 pi. Okay. and this is equals to you will use a transformation, but before using the transformation I would like to use one more thing. So which value will be greater? Whose graph will increase rapidly in x variable? Your voice is not clear, Roberto. Whose graph is whose graph is going to increase? Like which one is greater for all x? Please tell me. This is the very basic thing. Yes, fixed t. T is fixed. Which one is going to?
Then e to the minus x squared over 4t is greater than e to the minus, yeah, because the denominator will be greater. Oh yeah, so the x will be, yeah, sorry, it's inverse, yeah.
Isn't it? Because
Yeah.
this is negative, so this one is going to be less than this. So as soon as the denominator will be increasing, that will more increase. So it is e to the power minus function. That's why I was asking.
Yes.
So this can be less than or equals to c over t to the power n over 2 integration Rn minus b x naught comma delta e to the power minus x minus y square over 16t. There is a reason behind doing so. What, and then fix this x naught to x to x naught. This was the general x and then fix it to x naught. Now if you assume x naught minus y over 4 root t whole square, then we can take it as another constant c, take this transformation, then this t to the power n by 2 will vanish and it can be written as c Rn, and also when you will change this delta will be b 0 comma delta over root t, because here you will be taking under root t, g will be x naught minus y over 4 square root of t. So e to the power minus of modulus of z square 16. The authors haven't taken 4 inside z. This will tends to 0 as t tends to 0 plus, because when this will when t tends to 0 plus, so we are going to take the integral t is tending to 0 plus. Then we are going to take the limit Rn minus b of 0 comma infinity. 0 is with infinite radius. So this is going to cover the whole domain. This is going to cover the whole domain, means Rn minus Rn. It means we are taking the integral in the zero region at a fixed point. At a fixed point, so Rn minus Rn when t tends to 0 plus. In that case, this will converge to 0. It means we are taking the integral over single point, and this integral over single point is going to tends to 0 because integral is not taken over a single point. Hence, if modulus value of x minus x naught is less than delta by 2 and t is greater than 0 is sufficiently small. Now this z is tending to 0 when t is sufficiently small and I is less than or equals to epsilon. So suppose this is sufficiently small, suppose this is epsilon. So modulus value of u x comma t minus g x naught is going to be less than I plus j. It is going to be less than I plus j. And I is less than epsilon and j is also very small value. So we are assuming that j is also less than epsilon. So we can write that this value is going to be less than epsilon plus epsilon. And that is equals to 2 epsilon. It means for sufficiently small time t and x minus x naught is less than delta by 2, in that case this u x comma t will converge to z of x naught. Is it clear? Next we are going to write 2 remarks based on that. Solution u x comma t defined by initial value problem depends on the values of z of y at all points y belongs to Rn, no matter how far y and x are away. Even the initial datum z is compactly supported, its domain of influence on the solution u x comma t is still all of x to the power Rn as long as t is greater. What we have discussed, we are just writing that. So solution uxt defined by the initial value problem depends on the values of zy at all points y belongs to R, where the initial datum z is compactly supported. So basically this z, when this z belongs to CR n infinity L infinity Rn, so basically this is the definition of a compact function, then the solution u can be written as phi z dy. So this works as a compact support where this phi is a heat kernel of the given heat equation. This phenomena is known as the infinite speed of propagation of disturbance basis of the heat equation. Next point. The solution U defined by initial value problem is in C infinity Rn cross 0 comma infinity, even if G is only continuous, and more precisely U is real analytic in Rn cross 0 comma C infinity. This phenomena is known as smoothing effect of the heat current. Do you guys have any doubts?
No.
Is it clear to everyone? Everyone.
Yeah.
Okay, so I am stopping this class here. Still, I could not finish. I wanted to finish a lot of things today, and still I am left with a very large thing, so I could not finish. I will try to finish tomorrow. Like these 3 days, I am going to take a class of 1 hour 30 minutes all, because the last week I could not take a class. Okay, so see you tomorrow. Yeah.
Okay. Bye.
On Wednesday and Thursday, there's no class in the whole UNAM, right?
Yeah, but I would like to ask, is it okay if I take a class on Wednesday?
For me, it's no problem.
Yeah.
Yvonne?
Yeah.
Okay, Ricardo. I think Ricardo is not in the class. Just join. Okay, so because I have postponed 2 classes. Well, one was of your festival, so I cannot say that I postponed. It was your holiday, but one I postponed like for the last week. So I would like to take classes for Wednesday because I want to finish your syllabus by the end of this month with the exam. Because I am going to another country in December 1st week, so before that I want to finish all the things. Yeah, so I would try to schedule extra class the next week, and by the next week I will try to finish this unit again.
Okay.
Okay.
Yeah, but I'll see you tomorrow.